NASA says its Voyager 1 probe, the most distant human-made object in the universe, is still sending usable information to Earth. Launched in 1977, Voyager 1 has been making headlines for over 45 years by revealing some of the most shocking and unexpected secrets in interstellar space. Not only did NASA use the spacecraft to discover the massive storm on Jupiter and the rings around Saturn shortly after its launch, but it has also warned the world of Voyager 1's recent strange and seemingly impossible discovery that has scientists confused and concerned. The confusion arises because the information from the system controlling Voyager 1's operations in space does not align with the spacecraft's recent actions. What could this impossible discovery be, and what is the way forward? Join us as we take a trip to outer space and uncover what has been happening in our universe. Voyager 1 has been traveling through space for 47 years and continues to explore the regions beyond our solar system, known as interstellar space. However, it recently developed an issue that has puzzled the team of scientists and engineers who monitor it from Earth. Despite being 15 billion miles away and decades old, Voyager 1 continues to function well, receiving commands from NASA, executing them, and transmitting scientific data back to Earth. But a particular issue with one of its key systems, the Attitude Articulation and Control System, AACS, is causing concern. The AACS controls the spacecraft's orientation in space, ensuring that its high-gain antenna remains pointed toward Earth to send data. However, the data readouts from the AACS do not match Voyager's actual behavior, meaning the spacecraft appears to be operating correctly while the AACS data seems random or impossible. One challenge in addressing this issue is the vast distance between Voyager 1 and Earth in interstellar space. A signal or light takes 20 hours and 33 minutes to travel one way, so sending a message to Voyager and receiving a response takes over 41 hours. Despite this delay, the team has determined that the AACS is likely still working. Its irregular data readouts have not triggered a safe mode, which would limit operations to essential functions while engineers diagnose and resolve the issue. Interestingly, the signal from Voyager 1 remains as strong as ever, indicating that its antenna is still aimed at Earth. Scientists are now working to determine whether the AACS itself is generating faulty data or if another system is causing the problem. Until the team identifies the issue, they cannot predict whether it will impact Voyager 1's ability to collect and transmit scientific data. According to a 2022 NASA release, Susan Dodd, project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory, stated that such mysteries are expected at this stage of the mission. The spacecraft, now nearly 45 years old, has far outlasted the mission planners' initial expectations. Voyager 1 is also navigating interstellar space, a high-radiation area that no other spacecraft has ever traveled, presenting significant challenges for the engineering team. Despite these difficulties, Dodd expressed confidence that her team would find a solution. If the problem source is identified, they might fix it by updating the software or using backup hardware systems. Voyager has already demonstrated resilience over the years, operating far beyond expectations. Successfully, with backup systems, in 2017, Voyager 1 used thrusters that had been inactive for 37 years since its planetary encounters in the 1970s, and they worked flawlessly when needed. The probes, though old, have managed to conserve power by shutting down less critical systems over time, ensuring that vital systems and scientific instruments remain operational. Voyager 1's legacy includes one of its most historic stops, Jupiter. When it arrived in 1979, Voyager 1 made groundbreaking discoveries that transformed our understanding of the giant planet. For instance, it found that Jupiter has a ring system, a surprising discovery since scientists had previously thought only Saturn had rings. Jupiter's rings, faint and composed mainly of tiny dust particles, were revealed clearly through Voyager 1's close-up images. The spacecraft also studied the Great Red Spot, a massive storm larger than Earth that has been raging for at least 400 years. Voyager 1's photos provided detailed insights into the storm's structure and behavior, showing strong winds moving in opposite directions around its center, forming a complex weather system. Additionally, the spacecraft captured images of Jupiter's clouds, revealing smaller storms, lightning, and auroras similar to those on Earth. These discoveries enhanced scientists' understanding of Jupiter's atmosphere and weather systems. After exploring Jupiter, Voyager 1 continued its journey through the solar system and arrived at Saturn in 1980. This part of the mission was equally fascinating as Voyager 1 made several eye-opening discoveries about Saturn, its moons, and its massive ring system. One of the most interesting findings was the discovery of new moons around Saturn. The spacecraft identified several previously unknown moons, adding to the list of Saturn's natural satellites. These moons varied in size and composition, and their discovery expanded our knowledge of Saturn's moon system. Another impressive discovery was Voyager 1's detailed study of Saturn's rings. Before its flyby, scientists knew Saturn had rings, but Voyager 1 provided unprecedented close-up views and data about their structure and composition. It revealed that Saturn's rings are composed of countless individual particles, ranging in size from tiny grains to large boulders, all orbiting Saturn in a vast and intricate system. Voyager 1's observations showed that Saturn's rings are not solid but instead made up of numerous individual ringlets, gaps, and divisions. These features result from the gravitational interactions between Saturn's moons and the ring particles, forming complicated and constantly changing patterns within the ring system. Voyager 1 also captured stunning images of Saturn's moons, including its largest moon, Titan. These images provided valuable insights into the geological features and surface characteristics of Saturn's moons, helping scientists better understand their origins and evolution. Voyager 1 didn't stop at observing Jupiter and Saturn's physical features, it also took a closer look at two of the most intriguing moons, Europa and Enceladus, and made remarkable discoveries. These moons have intrigued scientists because they might harbor hidden oceans beneath their icy shells. Europa, one of Jupiter's largest moons, has long been on scientists' radar as a place that might conceal a secret ocean below its frozen surface. Pictures taken by the Galileo spacecraft, which orbited Jupiter from 1995 to 2003, revealed features on Europa such as cracks and ridges that strongly hint at a massive ocean lurking beneath the ice. These features suggest that Jupiter's gravity, along with the influence of other moons, could be causing significant tectonic activity under Europa's icy crust. The idea of an ocean beneath Europa's surface has excited scientists because where there is liquid water, there could potentially be life. Water is crucial for life as we know it, and if Europa truly has a subsurface ocean, it could be one of the most promising places to search for extraterrestrial life.